All right, everyone. It is Unit 1, Day 16, and we're dealing with scientific notation, and we're dealing with word problems. And what I'd like to show you is how to address the word problems and what operations to complete. Now, let's be clear. There are only 4 operations we're going to be dealing with here: adding, subtracting, multiplying, and dividing. So let's look for some keywords that we can use, and I'll fill them in here. I'm going to make sure that you can see this in the video. Yes, you can. And here we go. It says the weight of a flea is 9.4 times 10 to the negative fifth, while the weight of a tick is 8.36 times 10 to the negative second. What is the combined weight? All right off the bat, I see the word combined, and combined is another word for addition. I might also use the word total. I could also use the word altogether. If you see any words like total, sum, combined, or altogether, think addition. So what is the combined weight of both the flea and the tick? Write your answer in scientific notation. So let's go ahead and write down the first number, 9.4 times 10 to the negative fifth. And we're going to be adding 8.36 times 10 to the negative second. A rule from the previous lessons was that we would like to turn these, we can't add these because they have different exponents, so we have to balance those out. To get negative 5, which is the smaller, to turn into negative 2, which is the bigger, I need to add 3. And if I add 3, that means I need to move my decimal 1, 2, 3 places to the left to balance out the plus 3. So here's what I now have. I have 0.0094 times 10 to the negative second plus 8.36 times 10 to the negative second. And now that these are balanced, I put a smiley face next to those. I can simply add my first numbers. So I bring my first numbers together, 8.36 plus 0.0094. Notice I'm lining up my decimal places and double checking that you can see this. Here we go. We have 8.3694. And we go ahead and continue to use the 10 to the negative second. And there's the answer, right? So addition means combined or altogether, total or sum. And make sure when you add, you have the same exponents. If they're not the same, then you need to do the adjustment, get them the same, and then combine them together. All right, let's take a look at another one. And this time, we have a distant star. These distant star questions are tough for a lot of people. So let's see if we can break this down. What's the volume of the distant star? I'm reading the first piece. What's the volume of this thing? What is the volume of the distant star in cubic kilometers? Give your answer in scientific notation. This one doesn't have any key words. I do see the phrase times bigger, which makes me think that I want to set up this scenario that we had before. Right, so right away, this is where we put the times bigger. And I tend to put the small item here and the big item here. So let's see if we can use that again. A distant star is this many times bigger than Neptune. So that means Neptune is the small thing. So I'm going to go ahead and put Neptune here. And I'm going to go ahead and put the distant star here. And let's see if we can put some numbers in. Now, I see the phrase a distant star is 5.1 times bigger. So the 5.1 times 10 to the second is the times bigger space. So I put that here. All right. Now I read the second sentence. If the volume of Neptune, so we're talking about Neptune, is 6.3 times 10 to the 13th. So that goes here. All right, so now what is the volume of the distant star? What's the volume of the distant star? I think we have ourselves a question. So now without any key words, we do know that we're multiplying the two numbers they gave us. So here we go. I'm going to do 6.3 times 10 to the 13th and 5.1 times 10 to the second, and I'm going to multiply those. When I multiply numbers, I multiply the first term together. And since I don't have a calculator on these videos, I'll multiply them out by hand. Times 3, bring down a 0. 5 times 3 is 15. Carry the 1, and I get 31. 3, 1, 2, and 3. Once again, double checking to make sure I haven't, I've gone off the bottom of the screen. Slide this up a little bit. Here we go. and there's 2 decimals, so I have 32.13. So that's a little bit messy, but we'll keep it for now. And times 10 to the 13 plus 2 is 15th power. Now I'm happy with this, except that 32 is too high, so I'm going to rewrite it so that you can see it easier on the screen. I'm going to go left 1, up 1. So left 1 with my decimal and up 1 on my exponent, and I have 3.213 times 10 to the 16th. And while I feel great about this, you know, Get More Math, sometimes it gets you with decimals. I look at the last piece. It says, give your answer in scientific notation. We've done that. And do not include units. We're skipping the units. Round the coefficient, or they call this the coefficient. I'm calling it the first term. Either way, round the coefficient to the nearest hundredth. That's 2 decimal places, which means we look at the first 2 decimals. There's the first one. Here's the second one. And we look at the 3rd decimal place to decide if we need to round up or stay the same. And in this case, the 3 is not 5 or above, so I'm not going to give it a shove. So here's my answer. 3.21 times 10 to the 16th. It is on the bottom right-hand corner of your iPad screen. And there we go. So no keywords in that one, but I did see the phrase times bigger, so I knew that this sort of setup would make sense. I was able to take the numbers and put them in the correct spot and solve that problem. Now we have 2 more to go. The next one that I have that reminds me of a Get More Math question deals with a fast food restaurant. Let's move this down a little. A fast food restaurant sold 9.1 times 10 to the 7th hamburgers last year. This year they sold, well, a big number, 824 billion it looks like. What's the oh, there it is. What's the difference? I see the word difference, and though my add and subtract and multiply and divide has been taken away, it is worth mentioning that difference would be the key word for subtraction. So if you see difference, you should be thinking subtraction. So simple enough. I'm going to subtract the difference of burgers sold in 2 years. I'm going to go ahead and subtract the first and the second together and try to get myself an answer. The first thing that I notice is that these are not compatible numbers. One of them is in scientific notation, one of them is in standard notation. And since what we're learning right now is how to work with scientific, I'm going to go ahead and take the 824 billion and convert it into scientific notation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this becomes 8.24 times 10 to the 11th power. I can see that the 11 is way bigger than the 7, so this is definitely the bigger value. And since subtraction works easiest when we do big number minus small number, I'm going to go ahead and do minus 9.1 times 10 to the 7th power. Now, as you saw in 2 examples ago, if these are not the same, we cannot work with them. So I'm going to make the smaller one into the bigger one. I need to add 4, which means 1, 2, 3, 4. So now I have 8.24 times 10 to the 11th minus 0.00091 times 10 to the 11th. Now my exponents are the same, so now I'm in business. I'm going to subtract off to the side here. 8.24 minus, line up my decimals, 0.00091. And if you're doing this by hand, you're going to have to throw some placeholders in there. You're going to have to do some borrowing and some subtracting. Nothing that's too difficult. I have 8.23909 times 10 to the 11th. And now let's check the question. It says answer in scientific notation. I'm looking right here. Answer in scientific notation, done. Without units, good. The coefficient, again, I call it the first term. They're calling it the coefficient. That's fine. The coefficient may be exact, which is what this is, or rounded to 2 decimal places. And because they give me the option, you can do either one. If it were me, I would just type in the exact and not fight with it. If you're going to round to 2 decimal places, first and second decimal place, the 9 moves the 3 up. So you could also put 8.24 times 10 to the 11th. And either answer would be correct. The key component here, the key component here is that subtraction and difference mean the same thing. Now this video is going a little long. Let's go ahead and wrap this up with our last example. And finally, if we were trying to look for our add and subtract and multiply and divide keywords, I read the question through employees company A who's spent this many emails. How many times? Here we go. How many times? As soon as I see how many times, it makes me think of that same setup where the times goes here, small goes here, and big goes there. And now let's see what we can do here. So when it says how many times, that makes me think that this is the thing we're looking for. And automatically, I know I'm going to be dividing big divided by small. That's how this problem is going to work. I can recognize without even really reading the problem too much that the fourth is bigger than the second because that exponent is bigger than this one. So 5.36 times 10 to the fourth goes in the big spot. 2.68 times 10 to the second goes in the small spot. And how many times more will be solved by dividing the big and the small. So we'll go ahead and do that. 5.36 times 10 to the fourth divided by 2.68 times 10 to the second. Now I pre-did this problem. I know this number happens to go into 5.36 two times, which is really convenient. I also know 4 minus 2 is 2. So there's my answer in scientific notation. It says how many times more emails did company Q send than company A? There's no reason why we can't. It doesn't say anything about not writing it in scientific notation, so there's my answer. If you're curious, 2 times 10 to the second is simply 2 times 10 times 10, which means 2 times 100. So another variation on this answer would be 200. And I think Get More Math would take either one. And that is how you look for some key phrases for add, subtract, multiply, and divide, and then how to solve 4 questions.